Welcome to Instrumentation Measurement 2. In today's lecture, we are going to talk about the control valve. Before we proceed with the control valve, we need to know where is the location of the control valve in any control loop. And what is the control loop? In any process system, usually we have a control loop. As you will see in the figure, this control loop will contain at least three things, which are the primary element, the controller, and the final element. The primary element, or we could say the sensing element, where we measure the process value, and it will send the signal to the controller, where it will process the input and compare it to the set point, and will send a corrective action to the final element, or we could say the actuator. In our case, we are going to talk about the control valve, which is located in the final element. This control valve will manipulate the process line and will change the value or the process parameter as our desired set point. What is the control valve? As defined by the ISA, the International Society of Automation, the control valve is a power-operated device which modifies the fluid flow rate in a process control system. It consists of a valve connected to an actuator mechanism that is capable of changing the position of the flow controlling element in the valve in response to a signal from the controlling system. Also, the actuator defined by the ISA is a fluid-powered or electrically powered device which supply force and motion to a valve closure member. Either the valve or the actuator, both of them need a mechanism for movement, or we could say the motion conversion mechanism. It is also defined as a mechanism between the valve and the power unit of the actuator to convert between linear and rotary motion. The conversion can be from linear actuator action to a rotary valve operating, or from a rotary actuator to a linear valve operating. Okay guys, control valve can be categorized based on three main things: the function of the control valve, and the motion mechanism of the closure member of the control valve, and the design of the valve body and its actuator part. What do I mean by the function of the control valve? Let's take an example. The control valve can be categorized as pressure valve even though it controls the fluid flow physically, because the valve will control the pressure of the process line and will be manipulated by the valve. The next one is the motion mechanism of the closure member of the control valve. If the movement of the closure member is in rotary form, the valve will be called a rotary type valve, and so on. Also, if the movement of the closure member is linear, we will call it a linear valve. Then the final categorized, it is the design of the valve body and its actuator part. We usually know about the butterfly valve and the global valve. Here is an example: is the global valve. It can be called a global valve for the valve that has a globe shaped cavity inside its body. We can categorize based on the type of energy that will move its closure member. Like for example, the MOV, it is motorized operated valve. Major parts of the control valve. There are three major assembly for the control valve, which are as follow: the body assembly, actuator assembly, accessory assembly. Accessory assembly. It includes all the devices and parts that will complement the function of the control valve. They have different shapes and different function. Here a summarized description for some of them. The first one is the regulators. They are working as self-adjustment devices. Second one is the solenoid valve, usually used to control the valve by steering the signal to the positioner, causing the valve to go to the valve position. Third one is the limit switch. Those switches are indicator for the position of the valve, either at the full opening position or at the full close position. The fourth thing, booster relay. This is an air relay that to increase the capacity of the air inside a pneumatic tube. It is used normally to increase the stroking speed. The fifth is the IB converter. It is a transducer that will convert the electrical energy to a mechanical energy. The form of this electrical energy is in the current signal, and the form of the mechanical signal is in air pressure. And also you can see, I believe you saw it before in the lab, we have the IB converter. The positioner, lastly, it is a device used to put the valve stem or the closure member at the desired rate of the travel. Regulators. We have 6 types here in the slides, 4 on the slide and 2 in the next slide. The first one is the self-compensating pressure regulator with a spring loaded, and self-compensating pressure regulator with a weight loaded, and self-compensating pressure regulator with internal pressure loaded regulator, and self-compensating pressure regulator with external connected spring loaded regulator. Pilot operator regulator, and finally the automatic pressure safety valve. The solenoid valve. As we said before, it is used to control the valve by stopping the signal to the positioner, causing the valve to go to the fall position. There are other uses. We can use it to block the valve operating or to vent it under a specific condition. Usually, solenoid valve can be operating by assertive voltage, such as 240 volt AC, or 120 or 48 or 24 and 12 voltage DC. More than one solenoid valve may be connected in series to provide several interlock. The solenoid valve. As we said before, it is used to control the valve by stopping the signal to the positioner, causing the valve to go to the fall position. There are other limit switches. Those switches are indicated for the position of the valve. Either it is at full open position or at full closed position. They could be either contact switches or proximity switches. It will send the signal to the control room if it is activated, and the signal will be programmed in the controller either as a high position or as low position. Limit switches. Those switches are indicated for the position. Booster relay. As we said before, it is an air relay to increase the capacity of the air inside the pneumatic tube. It is used normally to increase the stroking speed, and it is helpful in supporting the positioner for more air capacity in quick time. Here we can see a real-life picture of the booster relay and a figure or a drawing for the booster relay. Booster relay. As we said, IB converter. It is a transducer that will convert the electrical energy to mechanical energy. The form of this electrical energy is in a current signal, and the form of the mechanical signal is in air pressure. It is used to move the pneumatic-based actuator, like for example, the diaphragm actuator. Positional. It is a device used to put the valve stem at the desired rate of the travel. Its purpose is similar to the current to pressure converter, the IB converter, but different function. In the following figure, it will show the positioner used in the control valve. Positional. It is a device used to put the valve stem at the positioner can convert the signal, whatever its type, to the proportional output signal, and this output signal will let the valve move according to the desired output signal of the controller. There are benefits from using the positioner as mentioned in the following. First, minimize the effect of fraction hysteresis and deadband of the valve stem. Enable signal range change. A positioner can amplify the income control signal when a greater actuating force is needed. For example, the income signal is 20 to 100 kilopascal. We can amplify it to 40 to 200 kilopascal by using the positioner and before we apply it to the actuator. Also, it will allow the signal reversal. The positioner can operate in either direct or reverse acting mode. Also, increase the response speed of the actuator. The speed of the response of the valve actuator depends upon the actuator volume and the flow rate of the control signal air. The positioner also has a larger volumetric output capacity than other pneumatic devices. It also allows valve flow characteristic to be changed. And finally, we can have split range operating. In the split range control loop, one controller is used to drive two control valves. Actuator assembly. It includes all the parts that will work to move the valve body closure member. It can be pneumatic or electrical types. We have diaphragm types, piston type, fan type, bellows type, and fluid motor type. Diaphragm type. A fluid powered device in which the fluid acts upon a flexible member, the diaphragm, to provide a linear motion to the actuator stem. The following figure will show the idea of this type. Diaphragm type. A fluid powered device in which the fluid acts upon a piston type. A fluid powered device in which the fluid acts upon a movable cylindrical member, the piston, to provide a linear motion to the actuator stem. The following figure will show this type. Piston type. A fluid powered device in which the fluid acts upon a movable cylinder. Vane type. A fluid powered device in which fluid acts upon a movable buffet member. The vane, to provide a rotary motion to the actuator stem. The following figure will show the idea of this type. Vane type. A fluid powered device in which fluid acts upon a movable buffet. Bellows type. A fluid powered device in which the fluid acts upon a flexible convoluted member. The bellows, to provide a linear motion to the actuator stem. The following figure will show the idea of this type. Bellows type. A fluid powered device in which the fluid acts upon a flexible. Finally, the fluid motor type. A fluid powered device which uses a rotary motor to position the actuator stem. The actuator can work based on one side for the fluid entrance, either for extending or retracing the stem. Also, it can work on two sides of the fluid entrance in the actuator. The mechanism of moving the stem for the actuator according to one entrance of the fluid is called a single acting actuator. But if we have the mechanism that will move the stem for the actuator according to two entrances, an actuator is called a double acting. Body assembly. It includes all the parts of the valve that will attach and hold or release the process fluid, and they can give the characteristic of the flow of this fluid. There are many parts of the body: the body, the bonnet types, and the bushing. There is also the part that contacts the control fluid, are called trim. It consists of the following parts: seat ring and cage. Okay, guys. The body is a part of the valve which is the main pressure boundary. The body also provides the pipe connection ends and the fluid flow passageway, and sometimes support the seating surface and the valve closure member. The bonnet consider partition of the valve pressure retaining boundary, which may guide the stem and contain the backing box and the stem seal. It may also provide the principal opening to the body cavity for assembly of a material part, or be integrated part of the valve body. It may also sometimes provide for the attachment of the actuator to the valve body. The bonnet type. Typical bonnets are either bolted, threaded, welded, or integrated within the body. Bushing. A fixed member which supports and or guide the closure member, valve stem, and or the actuator stem. The bushing supports the non-axial load on the parts and subject to relative motion of the parts. The parts that contact the controlled fluid are called trims. It can consist of the following parts as they are defined in the ISA: the seat ring and the cage. The seat ring is a part that is assembled in the valve body and may provide part of the flow control orifice. The seat ring may have special material properties and may provide the contact surface of the closure member. The cage is a part of a global valve surrounding the closure member to provide alignment and facilitate assembly of other parts of the valve trim. The cage may also provide flow characterization and or a seating surface for a global valve and the flow characterization for some plug valves. How to find the suitable valve? To choose the suitable valve, it is important to know the major data for choosing the suitable valve. Each one can be summarized in the following description. The flow rate capacity. It can be expressed in the term of the flow coefficient. Its symbol is the CV. It is defined as the gallons per minute of 60 Fahrenheit of water that will flow through a valve with an open pound per square inch pressure drop. The full transfer rate is considered here. Second, the mechanism of the movement. It is the method of the closure part movement inside the body. For example, it is linear movement or rotary. Normally, the rotary has a high flow rate but are exposed to the high recovery also, cavitation. Next is the body material. It is the material used to make the trim and the closure member of the body. The case body will hold the trim and the actuator weight. As a result, the body material should be considered also. Next is the pressure drop. It is the difference of the pressure between the valve end and the other end. In other expression, it is the difference between the upstream pressure and the downstream pressure of the control valve. Finally, is the fluid properties that include all fluid specifications that will affect in the choice of the valve. They can be a specific gravity or density, viscosity, the absolute vapor pressure of the liquid at inlet temperature, surface tension, composition, and thermodynamics critical pressure.